Hello world, hello Philippines, as promised. I'm getting late. As promised, we'll be able to give of reaction kinetics, rate law, problem solving. Okay, so I have example number one. This one. Okay. Pulpin lang siya. Siya klaro? Okay. So this is in the chemical reaction 2 moles of nitrous oxide plus 2 moles of hydrogen gas is equals to N2 plus H2O. What is the value of rate constant, overall reaction order, and reaction order with respect to nitrous oxide concentration and hydrogen gas concentration? Okay, like that. So we have our one, our tabulated form, our experiments 1, 2, 3, right? So this our reactants, okay? NO and H, di maklaro. NO and H. So very tired to write on a pen, okay? So this is just a short live streaming, okay? And this is initial rate. Okay, initial rate meaning small letter r. So in this type of example, I'm gonna write this one. So 2 moles of NO plus 2H2 is equals to N2 plus H2O. This one. This is the chemical reaction. Okay, so as you can see, the problem is showing the chemical reaction and it is already balanced. But actually, class, the number of moles are not really important for this because we are focusing on the reaction orders, okay, for each reaction concentration reactants, okay, concentration of NO and H or hydrogen gas, something like that, okay. So if we get the rate law, R is equals to K, okay, NO raised to the power X, and then H2 raised to the power Y. So this is our general rate law equation to be used. Two reactants involved, NO and H2. Okay, and we need to solve the X and Y, the reaction order of each reactant concentration NO and H2. Now, this X and Y is not equal with the number of moles here. Huh? The 2 of NO, like that. Okay, this is not equal for this. Okay, the number of moles in the reactants and the products, specifically the reactants, is not equal for the X and Y because the X and Y are reaction orders. Okay, like that. So we need to get the X and Y. Okay, so we have the concentration of NO here. Okay, starting from this one, first experiment, second experiment, third experiment. Now, so NO concentration first. We get this like this, okay. NO, okay, NO. So raised to the power X is equals to the rate of NO. So this is the first thing to do to to be used. NO raised to the power X, okay, is equals to R. You will just segregate this one by one, the letter, the H2 also. Okay, so you will use the delta for the experiment. Okay, and then the concentration of NO, you don't know yet, so you will find here, okay, what factor you will be able to multiply, okay, this one. Try to figure out experiment 1, experiment 2, if there is changes or there are changes of initial concentration of NO. If there's no changes, then you have to multiply with factor, of course, common sense. So from, what's this? 0.15, okay, starting from 0.15, experiment 1, 0.15, and experiment 2, 0.30. So from 0.15 to 0.30, it's gonna be 0.15 times 2 automatically. Okay, so let's say concentration of NO is to the power X times 2, 15 times 2, right? So times 2, multiply the factor of 2, this one. Okay, just follow the formula above. NOx is equals to rate. So NOx times 2, because from experiment 1 we have 0.15, experiment 2 0.30, so it's gonna be, you will multiply 0.15 by 2. Okay, like that, so you can get 0.30. Okay, so substitute NOx times 2 is equals to the rate. Okay. Okay, the rate is the rate. Okay, like that is equal to the rate. Okay, now, so the concentration of H after that one. Okay, so consider this one first. Okay, like that. So you're gonna be putting the concentration by 2 raised to the power X. Okay, immediately. So because this is the factor you will be able to use, so you're gonna be 2, okay, times raised to the power X is equals to R, in which you don't know. Okay, but in the experiment, this one, so the factor you'll be able to multiply will be automatic, your initial concentration to be used, okay, inside the bracket, raise it to power X. It's just the same, okay, 2 to the X is equals to R. R we don't know yet, but we have the value here, okay. So take a look. Okay, if we consider here from 0.15 to 30 and our R here, this is the R, okay, this is because this is initial rate, okay, R. Then, okay, so if it is the value is 0.84 to 3.38, we cannot say, if you first get this 0.15, you also first experiment. If you get it 0.30, you also second experiment. It's corresponding, okay. If you use the first experiment, use also the first experiment in the initial rate, okay. And if you use the second experiment, then use also the second experiment, so that you will be equal, okay, similar quantities to be used, okay, like that, huh? Experiment 1 also in the rate, experiment 2 the concentration rate also, number 2 in experiment number 2, something like that, okay. So in this case, we cannot simply say what factor you'll be able to multiply with 0.84 to obtain 3.38. This is a point, okay. It's very difficult for this, is points. All you have to do algebra, okay. So algebra, 0.84 multiply to something, so rigid mo matter, no? So 0.84 times multiply to something, okay, multiply to something, let's say another variable, not to confuse the x and y, let's say z, okay. Let's Z is the factor to be multiplied. Z, okay, to equal with the second experiment, which is 3.38 here. Okay, so solve for the value of Z. So Z is equals to 3.38 divided by 0.84. So Z is equals to like this, 3.38 divided by 0.84, 4.02, or shall we say 4 na lang siya, kay factor man siya. But to be exact, let's 4.02 in the calculator. Okay, 4.02. Okay, because we divide this 3.38 to 0.84 for the experiment here in the 1 and 2. Okay, we use the let Z is the factor to be multiplied because this is not easy. This is not a whole number. Okay, we cannot say times 2, times 3, times 4 because this is not a whole number. That's the problem also when you keep on trial and error what factor you'll be able to multiply. Okay, because this is this is a point. Okay, that is only good for whole number given, or it could be multiplied by certain whole number to equal to the second rate, like that. But in this case, the second rate is also point something, so we need to let Z is equal to the factor to be multiplied to get what is the necessary initial rate for that. Okay, so that is 4.02. Okay, 4.02. Okay, so since you let Z as your factor to be multiplied by 24, Z is equals to 4.02. So Z is just equals to R. Okay? Because I don't want to confuse with the small letter R rate low. Because this is only factor that you multiply, right? This is not the rate actually. Okay? But since you are computing for the rate low, so it will just be equal directly. So it's equals to 4.02. Actually, you can also have equal point R also. 0.84 times R is equals to 0.38. Okay, here. You can use R also here, R like this. My purpose only is to have another variable because it is a factor to be multiplied, not directly the R. Okay? But actually, you can use also the R because it's just totally the same. You will be use the value as R here. Something like that. Okay? Okay, R is equals to 4.02. Okay, this one. So we have now 2 raised to the power x is equals to 4.02. So just try to neglect the 0.02 because you are dealing here with the reaction order. There's no reaction order with point something. Okay, there's a negative fraction, but there's no point something, 0 something of the reaction order. So you have to consider 4 only. So you can say now 2 raised to the power x is equals to 4. This one. So 2 raised to the power x is equals to 4. So solve for the value of x. Okay, so 2 divided by 2, 1 is common denominator. 4 divided by 2 is 2. So x is equals to 2. Algebra. Okay, x is equals to 2. So you have now the reaction order of x for the NO equal to 2. Okay, so you have to put now the 2 here in the NO here. NOx equals to 2. So your reaction order of NO is 2. Okay, so you answered already the first question here that states what is the reaction order with respect to NO. So our reaction order with respect to NO, this is NO, is equals to 2. So second order, the NO is second order. Okay? Like this. Oh, Jake, 101 vlog, thank you so much for watching. You're still listening. Okay? My gosh. Thank you so much. Okay. Now we compute for the H2. Okay. H2 concentration, we see the power Y. Okay. Y is the reaction order is equals to the rate. Ganun pa rin siya. Iniwalay mo lang siya. Okay? Because you cannot get if you will not segregate this each reactant. So we are now here in this portion, right? H2 raised to the power Y. Okay, H2 raised to the power Y is equals to R, where Y is the reaction order. Now go back to the experiment. We have also initial rates for H2 here. Okay, take note in the first experiment of H2 here, ha? Tapos na tayo sa NO. So H2, so you can say initial concentration in experiment 1 is what's this? 0.15, and also 0.15 in experiment 2. Do not use that because there's no change. We are concerned for the change in the reaction rate man siya. So go directly to the number 3. So we have from what's this? From 0.15 to H2, from 0.15 to 0.45. Okay, 0.15 to 0.45. Okay, what factor you'll multiply by 0.15 so that it will become 0.45. It's very easy. So whole number only siya. Okay, because if you times by 3, exactly you can get 0.45 man siya. Okay, it's not the same with the other NO because 3.8 something, 2.27. It's not easy to multiply with a whole number. That's why we need to use algebra. Let Z or let R equal to the factor to be multiplied to obtain the initial rate. Ganon. Okay, but this one is to be multiplied by the whole number only is very easy. Okay, so times 3 siya. Okay, H2 concentration raised to the power Y times 3 siya is equals to R. Ganon siya. H2 raised to the power Y times 3 is equals to R. 3 is the factor to be multiplied. So, badin, it will be equal to, isud mo ang 3 sa H2. So, 3 raised to the power Y is equals to R. So, 3 raised to the power Y is equals to R. And our problem is the initial rate R. Okay? And we have also in the experiment here that indicates that we have also the initial rate here. Okay, the same with the NO we used too. But observe if there's changes, ha? Okay, like that here. Now, if you are using the 1 and 3 for the H2, you'll be also using the initial rate from experiment 1 and experiment 3 also, so that to compensate the equality or equilibrium. That's gonna be the rule. If you use experiment 1, use also the experiment 1 for the initial rate for that. Experiment 2 use also experiment 2. Okay, but before choosing that one, you need to know the changes first. If there's no changes with the concentration between the two, then don't use that. Use the other, the other data after that. Something like that, okay? So corresponding siya. Okay? Then, so 0.84, again, point something, it's very difficult. So we let R na lang siya diretso, okay? So that it's easy. Okay, kinatagga man ta sa let Z. Okay, and then Z, we get the value of Z for the NO, and then we put that also as equal to R. So let's make this R directly. Okay, like that. So experiment 1 for 0.84. Okay, 0.84. Let R as the initial rate as a factor to be multiplied by 0.84 to produce, so 0.84 times R, right? So to produce, okay, which is 2.53. Okay, we do this type of algebra because it's not easy to multiply with a whole number because point something, okay? So R is equals to 2.53. Maglabad na natong O. So over 0.84. Kung unsa atong i-times, okay? So let's use algebra in this case, okay? Okay. So, yung ato manggod siya, trial and error, i-multiply mo siya tagsa-tagsa para lang makakuha ka niya, pilay mong i-multiply, gano'n. Pero ganahan dyan ko ani niya, kaya because algebra siya, it's easy to understand rather than the trial and error method, okay? So this one. Okay, so 0.84 times the R, because we let R as the factor to be multiplied to produce the initial rate of 2.53, which is the experiment number 3. Okay, so our initial rate is equals to 2.53 divided by 0.84. Use the calculator now. Okay, So 2.53 divided by 0.84 is equals to, okay, 3. 3 siya. So the initial rate is equals to 3. So you have to multiply with 3 siya. So our rate is equals to 3 because we let R already as our unknown. So 3. Okay, so put the 3 here in the R. Okay, so it's gonna be like substitution, direct substitution. Okay, so 3, charot ay, 3y, matulog na ko. 3y is equals to 3. So this is our equation. Okay? Okay. 3 is equals to, okay, 3 raised to the power y. Or 3 raised to the power y is equals to 3. Y is the reaction order of H2. Okay? Like that. So, the base is just the same. So, it will be cancelled 1, 1. Okay? Pariho man siya. So, 1, 1. So this is 3 understood to be raised to the power 1. So, y is equals to 1. Like that. So, y is equals to 1. So, our reaction order for H2 is equals to 1. Here. Okay. Reaction order of H2 raised to the power y is equals to 1. So, our hydrogen gas reactant concentration is a first order reaction 1. Now, we obtain already the 2, right? So, we put now in our original equation of rate law, which is this one. Okay? We already compute the X, the reaction order of NO. We already compute the Y, the reaction order of H2, then substitute. Okay, we have now rate is equals to KNO, nitrous oxide, X is na-compute na nato siya, 2, and then H2 is equals to 1 here, okay, because na-compute natin siya. So, 1. So, it's gonna be like this. Our new equation, okay, like that. So, equation 1, equation 2. So, in our equation 2, we already put the reaction order. Okay? Okay, so the question here is already answered in the problem. Okay, so what is the reaction order of H2 concentration? So our H2 concentration, mamani siya ang Y. So 1. So first order ang atong H2. Okay, so now another question here. What is the overall reaction order? So overall reaction order is very easy. So X plus Y. Okay, overall reaction order. So I will just put ORO, overall reaction order. Oro, Cagayan de Oro, Banco de Oro. Charot. Okay? Overall reaction order, ORO, is equals to X plus Y siya. So, X is 2 here and 1 ang Y. So 2 plus 1. So 3. Our ORO, overall reaction order of this chemical reaction is 3. Okay, in this 2 moles of nitrous oxide plus 2 moles of hydrogen gas will produce 1 mole of nitrogen gas plus 1 mole of water. Okay, so our overall reaction order is 3. Okay, our reaction order with respect to nitrous oxide is 2, and our reaction order with respect to hydrogen gas is equals to 1. Now, what is the other required? What is the value of rate constant? Now, we have here the value of the rate constant, and we can compute here to this equation, right? R is equals to K NO raised to the power 2, H to the power 1. Now, our R here is initial rate for this NO and H2 because we are referring for initial rates only, not the final rates. Okay, like that. So in our experiment again, we have to look our initial rate that started with 0.84. So 0.84 with the unit of molarity over second. So we have to substitute that in that equation. So you can substitute that here. Okay. And then solve for the K's. Again, algebra. So, K is equal to, ganun siya. So, K is equals to, akong i-diretso because it's very easy. So, R, so, NO to later investigate the unit. Okay, units. If the units will not agree, then you have a wrong answer. Okay, our K is equals to the rate low, okay, rate of chemical reaction over the initial concentration of NO, okay, raised to the power 2 and H2 raised to the power 1. Okay, so it's very clear that this reaction order is not the number of moles given in the original equation. Not be confused. Okay, because other other topics in chemistry, the number of moles will be raised to the power and the exponents also, but here is different in chemical reaction kinetics. Okay, like that. And substitute the whole thing in the in the experiment. Okay, so in the experiment 1, this 3, okay, 1 2 3 for the H2 and the and the what's this one, NO. Use this because the first reaction, the first experiment is our initial concentration, okay, and our initial also K. That's the word initial because number 1, okay, starts with number 1. So all of them will substitute in this rate law equation here, okay, and then bingo, ganon. Okay, so R, isa man siya, pila. Tanawon din mo diri. Okay, so R, Bisaya. R is equals to 0.84. Okay, so 0.84. Later, we will be investigating the unit, so that we can cancel what is really the unit of the third order, overall reaction order of 3. Okay, so 3 is equals to 0.84. Okay, ganon. And because I don't want na mulubog siya, okay, during the substitution effort. Okay, so NO is equals to 0.15 initial concentration, so raised to the power 2, okay, and H2 0.15 raised to the power 1, okay, like that. Okay, so no need to raise to the power 1 because if there's no power 1 here, it's just equal to 1. Okay, something like that. So our K now, so calculator for please, charot. Okay, so 0.15 times 0.15 equals to times 0.15, so equals to 3.75 times 10 to the negative 3 exponential. Okay, but it's very easy because that's raised to the power negative 3 and you have to move only in the left if it is an exponent negative, okay, left, and then if it is exponent positive, you move to the right. That's the rule also in algebra. Okay, 3.375 times 10 to the negative 3.84. So, okay, what is the value for this? Again, calculator. Oh my gosh. So 0.84 divided by 0.00375 is equals to 249 is your K. Okay, 249 is your K. Now class, we need to investigate the units. Okay, incorporate the units now. Okay, so in the numerator, the units of 0.84 here in the experiment is molar per second. So substitute now. So molar per second. And then the NO here, we have the molar only. Okay, units ta. Okay, I do it individually so that it will not be confused. Actually, you can do that also there in the formula. It's up to you, but to make it clear only. Okay, so H2 is M also, M, so M, but NO raised to the power 2, so M here will be raised to the power 2. Okay, so you can cancel a lot of M right here in this. If you simplify this one, you can cancel a lot of M here, so it will now goes to something like that, this. So M cubed, okay, cancel, so this becomes 2 like that. So in the second, so your answer will be 1 over M, okay, negative 2 second, okay, like that. Okay, this one, this is will be unit of your K, 1 over M to the 2 raised to the times S. Now investigate if it is correct. right? Because we have the formula of K also is equals to capital M raised to the power 1 minus N times T raised to the power negative 1, and then the value of N will be 3 because we said our overall reaction order is 3. So let's just prove this one, that is our unit for K is will agree really for the third order. Maybe wrong, right? So we don't know. Okay, so K is equals to M 1 minus N, our N overall reaction order is 3 as I mentioned earlier. So times T negative 1, this one, huh? Okay, like that. Substitute the N negative, the 3. Okay, so this will become M negative 1 minus 3, negative 2, 10 negative 1. So it will become to 1 over M2 T and then 1 over M2 seconds. So it's equal. So guys, it is perfect. Okay, the unit of K is equal with this one if you substitute for the standard formula of the rate equation constant in a third order overall reaction. Ganon. So if N is more than 3 overall reaction rate, you don't have to worry because you can substitute that here. So you can easily detect the unit even though the reaction order is 2002, 212, 10, or infinite. Walang katapusan. As long as you will substitute in the equation, which is K is equals to M 1 minus N, like this, blah blah blah. Okay, here. Okay, like that. So our K here is 249. So meter 1 meter raised to the power 2 squared meter, right? Square meter second, ganon siya. Ganon siya. Okay, so our rate equation constant, our reaction rate constant is 249, 1 over N2S. So this is our, we had answered already the question, which is what is the value of rate constant? Okay, so all the questions have been answered. Value of rate constant, overall reaction order of NO and H2. So 1, 2, 3, 4 of 4 answers. Okay, it's gonna be like this. Okay, already solved all for this problem. Okay, this one. Okay, it looks like a confusion if you don't know really what factor to be multiplied, but don't you worry, we use algebra only. Okay, for example, 0.15 times the factor to be multiplied is equal to something. Okay, and we solve for the value for the factor that you let that as X, as Y, and then you can determine what number to be multiplied. Ganun lang siya. Because if you keep on guessing numbers, what factor in order just to equal for the third experiment, blah blah blah. So it's not easy. Okay, it's very difficult also, right? So you will use always let X, let Y, let Y. Ganun siya parati. Okay, just like in balancing equation, number of atoms and balancing of charges. If you can remember, I always let X, let Y, let variables to solve, because as long as there is an equilibrium or the equal sign, then you can solve for the value of the variable what is being required. It's very easy unless there's an exponential. Okay, exponential meaning x to the 2, x to the 3, x to the 1/2, but most of the times in these cases we don't have exponent. Okay, like that. So it's very easy to solve for the value of the letter x, y, z, blah blah blah, so and so. It's just the same also. Okay, then other explanations also in the in the pictures I saw is very difficult, and you have to think also. It's gonna be like this, okay, and you will compile all your stat knowledge regarding this topic. Okay, thank you so much. If you think you'll learn only one example because katugon ako. Okay, actually there are 9 examples. Tomorrow I'll be dealing with other 8 examples. Okay, class. If you see a question like this, okay, you have already an idea. Okay, so unless they will they will rotate they will steer, or they will confuse the students. Okay, they will try to incorporate another thing which is not necessary. For example, in this problem they will add density, ganon. They will add mass, they will add another quantities, the force, and then it is not necessary for the problems. Okay, most of the times gonna be like that. Okay, that's why the students will be confused during the examination, because there are given and data that is not really useful if you will solve the answer. Okay, it's just only a jargon, meaning hypothetical, which is irrelevant if you solve the solution, but relevant to the problem because at certain, for example, at a certain temperature, this will be the value of this concentration, gaganon. But you will not use the temperature in your solution, only the concentration. It looks like that also. Okay, so you will not be bothered by other, other quantities, physical quantities. Okay, and then use only what is being required based on your solution. Okay, then the difficult also in the integrated rate law. This is only rate law which is not unintegrated. Okay, so there you'll be using the logarithmic functions, ganon. Okay, so you will be confused. Okay, because it's using integral calculus. Okay, to solve for the the rate constant, the rate law, blah blah blah, so and so. Okay, like that. Okay, so if this is a overall reaction 3, so we cannot really determine what is the graph for this. Okay, unless we will plot this. If we will plot this one by one in the in the graph paper, or if now we will plot this one, we can produce the shape of the graph. Okay, but it is not asked for the problem. Okay, why we will do that? Okay. Okay, because what's presented in the in the theory is only zero order reaction, first order reaction, and the second order reaction, the drawing. But the others from 3 to up, it's not shown what really the appearance of the drawing. Maybe the problems will show also like that. What is the graph, or illustrate the graph for overall reaction of 5 o ganon. So you have to plot one by one like that, blah blah blah, and you can show maybe it's a parabola, a hyperbola, ganon, or a straight line only, a curve facing downward, a curve facing upward, something like that, or a curve facing left, a curve facing right, ganon siya. Okay, or it could be what else like a curve like that, curve going down, curve going up, something like that. Any kind of shape, as long as if you connect the dots or the data of the experiment 1, experiment 2, experiment 3. Actually, this is just simple because it's experiment 3, but others also having experiment 1 until experiment 10, ganun siya. Okay, now in that case, so you will go to the initial 1, experiment 1, experiment 10. Okay, because the theories peak final man siya. So concentration final minus concentration initial. Okay, so your concentration final, the last one. Okay, so use that one. Okay, maybe you will also use the number 2, ganon, but use the 10. Okay, C1 and C10 data, use that one because that is final and initial. Okay, like that. Okay, if you really want to plot everything, then you can also 2 and 1, okay, 3 and 1, 4 and 1, 5 and 1. As long as the number 1 experiment is always your basis because that is an initial concentration. But if you want to go one by one, then you have to plot that one in a graph. So consider that 2 and 1, 3 and 1, 4 and 1, 5 and 1, 6 and 1, 7 and 1, 8 and 1, 9 and 1, 10 and 1. Because 1 is your basis. So we call initial. Okay, initial concentration. Okay? Like that. Okay, so the initial concentration is very important because you will substitute that in your general formula to obtain the rate equation constant, not the number 2 experiment, number 3 experiment, number 4 experiment, because it's the number 1 we will be using as a standard. Okay, sa una gid siya, original. Okay, ganon. Thank you so much for watching. If you like this video, then you can click the notification bell from some newest updates of I Am a Singer Eternal Voice regarding occupational safety and health science, pure sciences, personal vloggings, and singing entertainment. Thank you so much. Bye bye. God bless everybody. Bye bye. Okay.